Welcome to This Explainer. I am so thrilled you're here today because honestly, we're going to demystify something absolutely massive. Have you ever tapped an icon on your phone and just wondered, how on earth did they actually build this? Well, today, we are going behind the screen. We're going to unpack the entire journey of an app, right from a simple idea scribbled on a napkin, all the way to a fully functional tool living right there in your pocket.
Okay, let's dive into this. Here's our roadmap for today. We'll kick things off with a welcome to software engineering. Then we'll meet your software team. From there, we'll walk through planning and designing, building and testing, launching and maintaining, and finally, we'll take a quick look at the future of software.
Section 1. Welcome to Software Engineering, moving beyond the chaos.
Now, if you're an absolute beginner, don't worry at all. We are taking a structured, step-by-step journey today. So, what exactly does it take to turn a digital idea into reality? Well, imagine trying to build a massive skyscraper, right? But you just show up with a pile of bricks and zero blueprints. It'd be a total disaster. That is exactly what building digital tools is like without software engineering. It is not just some lone genius typing code in a dark room. It's about methodical problem solving and intense collaboration, ensuring the whole structure doesn't just collapse when a million people try to use it at the exact same time.
Then think about it. You rely on this every single day. Whether you're transferring money on a banking app, ordering new shoes online, scrolling through social media, or even when doctors are pulling up patient data in healthcare systems, all of this operates smoothly because of rigorous software engineering. It literally powers our modern life.
Section 2. Meet your software team, the specialists behind the screen.
Building software is essentially a highly collaborative relay race, and these right here are our runners. First up, we've got the business analyst, figuring out exactly what the app must do. They pass the baton to the UI/UX designer, who designs the visual interface. Next, the software developer actually writes the code. They then hand off to the QA tester, whose entire job is to find bugs. After that, the DevOps engineer steps in to ensure a perfectly smooth launch, and running alongside literally all of them is the project manager, keeping everyone on track. The real magic? It happens in those handoffs between these distinct roles.
Section 3. Planning and designing, setting the foundation for our food delivery app.
To make this super concrete, let's imagine our team is building a brand new food delivery app. We start by laying out the actual track for our relay race using something called the Software Development Lifecycle, or SDLC. Every professional team uses the 6-step map: requirements, design, development, testing, deployment, and maintenance. It's how they turn a wild idea into a polished product without completely losing their minds.
Let's look at the very first step on that map, the requirements phase. Here is our first major baton pass. The business analyst sits down with restaurant owners and hungry customers to figure out exactly what they need. Those customer needs directly dictate the app features, which then form our overall development plan. So the analyst figures out, hey, users really need to be able to filter by vegetarian options. That specific requirement is absolutely crucial to nail down before anyone writes a single line of code.
Once all those needs are gathered up, the business analyst passes the baton over to the UI/UX designer. This brings us to software design. This is the phase where the system architecture and user interface are completely planned out. The designer visually drafts exactly where the Order Now buttons will go, what colors to use, and how the app is actually going to feel in your hand. To really understand how the UI/UX designer thinks, you have to trace the journey. The user interacts with the app interface to browse the menu, right? And when they finally hit order, that information seamlessly connects back to a database. The designer's entire job is ensuring this journey is intuitive and totally frictionless. Think about it. If a hungry user can't find that checkout button in just 2 taps, the design has failed.
Section 4. Building and testing, turning designs into reality and squashing bugs.
Okay, so the blueprints are drawn, the design looks beautiful, and now the baton is passed to the heavy lifters of our relay race. First up is the development phase. The software developer takes those visual blueprints and builds the actual working app by writing code. They use programming languages like Python, Java, JavaScript, or C#. Just like a construction worker uses hammers and drills, developers use these specific languages as tools to construct the digital building. So the crucial point is how this transformation actually happens. Abstract ideas are literally translated through code into functional app features. The developer writes the complex logic that essentially says, hey, when the user taps this button, deduct $20 from their account and send an alert directly to the pizza shop. It is a massive jump from a concept to a living reality.
But humans make mistakes, right? Which is exactly why the developer immediately hands the baton straight to the QA tester. Welcome to the testing phase. The tester's entire job is to literally try and break the app before the customer ever sees it. They run unit, integration, and system testing. Basically, they're going to try to crash the checkout cart by adding, say, 1,000 pizzas all at once, just to see if the app can handle the pressure.
And it forms this continuous looping cycle. The developer writes the code, and then the QA engineer runs a test. If they find a bug, and they usually do, they send it right back for a fix, and then they retest it. They just pass that baton back and forth over and over until our food delivery app runs flawlessly. It really shows how deeply connected the team has to be.
Section 5. Launching and maintaining. Going live and keeping it running.
Now we are in the final lap of our relay race. We have a functioning, bug-free app, but it needs to actually meet the real world. Enter the DevOps engineer. During deployment, they release the software to the users by pushing the app up to the cloud. But they don't just walk away. They also provide ongoing updates, crucial security fixes, and basically ensure that no one can hack in and steal our pizza orders. In this final, critical handoff, the DevOps engineer takes that polished, final code, pushes it securely to a cloud server, which then distributes it seamlessly to millions of users' mobile phones. It is this massive, complex logistical operation that happens perfectly in milliseconds behind the scenes. Now, there are generally two popular ways a team can run this entire relay race. The classic waterfall model is a very strict linear progression. You finish one phase completely before you even think about starting the next. But then there's the agile model, which is what most teams use today. It's a flexible, looping cycle. Agile is great because it lets the team adapt quickly if, say, the restaurant owners suddenly change their minds about what features they want midway through the build. Section 6. The future of software. What's next in the engineering world?
The processes we've just learned are the gold standard, but the tech world moves at absolute light speed. The challenges these software teams face are immense. Tight deadlines, constantly changing requirements, you name it. But trends like artificial intelligence, cloud computing, and automation are rapidly changing the whole SDLC. Today, AI can actually help developers write code faster and even assist QA testers in finding bugs automatically. The tools are evolving, making software engineering faster and way more powerful than ever before. Let's move to and see how this builds your own path. My ultimate call to action for you today is simple. Learn programming. Just start with something easy, maybe Python. Build a small project. It could be a simple text-based game or even just a basic calculator. You now understand the map. You know how the team works. All you have to do is take that very first step and explore software engineering firsthand. I'm going to leave you with this final, somewhat provocative thought. Software engineering is this massive, deeply collaborative team effort. But as AI and automation continue to completely reshape exactly how we build these apps, where will you fit into the software team of the future? Will you be the visionary designer, the coder, the relentless tester, or maybe the one directing the AI itself? The digital frontier is wide open and waiting for you. Thank you so much for joining me on this explainer.